So in this problem, we are given that we have a particle that has kinetic energy of 5.3 mega electron volts, and we are asked to find the force on this particle. So we know that the kinetic energy, in order to find the force first, we need QV crossed with B, right? So in order to get V, we need to use the fact that K is 1/2 mv squared, which means that V is square root of 2K over M. So V equals square root of 2 times 5.3 mega electron volt times 1.60 times 10 to the negative 13 joules for every mega electron volt divided by the mass. We have a proton, so 1.67 times 10 to the minus 27 kilograms. That gives us a speed of 3.2 times 10 to the 7th meters per second. And so now we can say that F, the magnitude of the magnetic force, is QVB sine of theta, and since we're looking for magnitude, we can take the square root, the absolute value. So 1.60 times 10 to the negative 19th coulomb times the velocity, which is 3.2 times 10 to the 7th meters per second, times the magnetic field, which is 1.2 times 10 to the minus 3 Tesla, times the sine of, well, the magnetic field is vertical, upward, and the particle is moving horizontally, so this is perpendicular to each other. And that gives us a force of 6.1 times 10 to the negative 15th newtons. And furthermore, we can find the acceleration if we want. This is the magnetic force over the mass, which is 6.1 times 10 to the negative 15 newtons over the mass of 1.67 times 10 to the negative 27th kilogram. Gives us an acceleration of 3.7 times 10 to the 12th meters per second squared. The reason we do this is you might have thought that the force is very small, but if you look at the acceleration that force generates, it's very, very large. So now we're asked to find the direction of this force, and for that we can use the fact that if the force equals QV crossed with B, then we can use a right-hand rule to find the direction. Since Q, V, and B are all positive, then the direction of F of B is going to be in the same direction as the direction of V crossed with B. And if you look at these directions, you put your fingers in the direction of the velocity, which is horizontal, and then you curl your fingers into the direction of the magnetic field, which is vertical. So you notice that your thumb is pointing out of the page, which is the direction of the force in this case. We can practice these more during some of our Zoom meetings if we need to.